All right, we're back. This time I took all the loads off of the circuit. I'll put 2 loads on later, but I just want to show you the closed loop. It's a total closed circuit that you can bridge across and get power, which doesn't make any sense because I don't feel it if I bridge across it as a load because I'm, I have more resistance than the loads. So, current always chooses the path of least resistance. But here's basically the simplified version of what's going on. You got a high frequency, high voltage oscillator. In my case, like I said, I'm using a flyback transformer from an old CRT television. But at the bottom, and then you go up there, you have your 2 outputs, and you have a spark gap. Let's see, we're not focusing. Let's go landscape. You got your spark gap right there. And then you have your 2 capacitors in series coming off the spark gap. Now here's what's crazy about the circuit, because it's a loop after that. What's crazy is everything should always be jumping across this and not caring about this loop, because that's an easy path, right? And there's capacitance here and high inductance to cross over, so that would be the easiest path to take, and it does take that. That gap never stops quenching or, throwing a spark. But at the same time, something weird is happening here, because I can't hook this thing up to both on one side. Both leads to one side. Has to go across this bridge, even though the same freaking wire connects them together. Okay, so I wanted to show you that. Now let me hook back up. Couple loads here. Once again, the incandescent from a microwave oven, 110 volt, 30 watt. We'll put that one on first. You know what? Tesla says he actually, in his diagram here, he shows, I don't know if he's showing brilliance in these different setups, but here's his oscillator down here. It's like a, a turbine motor or what have you. Then it goes through his transformer. The dual coils, steps it up, and then he's got his capacitors here with the spark gap in between them. And these 3 different modes he's showing. With 4 loads on this one, right? There's no bridge. He's got a load at the top instead of the bridge up there, which I don't have. He's showing a fluorescent, I guess, here, a gaseous bulb, which is really brilliant if you put it at the bottom, supposedly, like down here, right above the caps. And then he says a higher wattage should go above, and then or the highest wattage should go below, then lower, and then lower, and then lower. And I read different things from different people saying the opposite, so I don't know. From what I've seen, the incandescent runs best down low, and the lower wattage applications run best up high. So we'll figure it out. This is first day playing with this crap. So we'll take this back up, put this one on the low side. And kids, you always want to discharge your oscillators and all your capacitors. Look for that spark. You don't want to hurt yourself, kill yourself. Don't do this at home anyways. This is not for you. Yeah, anyways. So we'll hook this back up. And always use your one hand when you're working with high voltage, so it doesn't bridge across your chest in case you make a mistake. Defibrillate and kill your heart. Don't want that to happen. Alright, so we're hooking this up. So it's just bridged across. Oh, that's right. I wanted to show you this before I hook this up. Sorry. So before I hook this up, let me just turn this on. And I'm going to touch different areas. Nothing's going to happen to me. So we're going. Nothing's connected. It's just the loop. Right? I'm touching. Nothing. But watch this. Let's see how I can do this. How can I show you what I'm trying to explain here? Let's see. Let's see. See the frequency change when I add the short? Right? So we'll put that back on. Run it. Frequency changes, drops really low. We got nothing hooked up as a load. Now we'll look up our loads. Once again, I could touch anywhere. Nothing's going to happen to me. It's a different kind of juice running through this stuff. Can't explain it. There we go. We're lighting up. Let's hook up a second load. Throw this bad boy right here. Got one pin in. Got another one in. Oh, look, real power. Let's see. All right. Second load. Check the transistors, heat. Yeah, we're getting warm. First load was down a little bit, but it's still lit. Oh, it was until the clip came off. Alright, still lit. Let's get the water out here now. We got some water. Now, would you throw alternating current in your bathtub? Ever? I don't think so. I'm in there right now. Both leads. Still lit. Still going. Transistor's getting hot. I'm going to shut her down. I'll be back.